So like we said, your exam is 20 questions, all multiple choice. So we're going to start with number 1. You have 3x squared plus 7x minus 2 divided by x minus 4. Remember, when you're using long division or any kind of division, you are going to put that binomial on the outside, and anything else goes on the inside of your division house. However, you need to make sure that you have every power represented, or every term represented, from your highest power term to your lowest. So you have an x squared, an x, and a constant. You're good. So you're going to put that x minus 4 on the outside, and the 3x squared plus 7x minus 2 on the inside. So your x multiplies by 3x to make it 3x squared. That 3x times negative 4 is also negative 12x. So you are going to subtract these, distribute that negative. So you change the sign on each of the terms. Your 3x squareds cancel. Your 7x plus 12x gives you 19x. And you drop down that negative 2. From there, you start all over again. So that x on the outside multiplies by 19 to give you 19x. The 19 times negative 4 gives us 76, or negative 76. You are going to subtract, distribute the negative. Your 19x's cancel. Your negative 2 plus 76 gives you 74. That 74 is your remainder. So you're going to write this as 3x plus 19 plus 74 over x minus 4. For number 2, you're using synthetic division to divide, and you're given 3x cubed minus 2x squared minus 11x plus 9 divided by x minus 2. You're going to start by taking that x minus 2 and solving it for x. So you're going to add your 2 over, and that gives you that x is 2. That's giving you the number that's going to be on the outside of your synthetic division. So you put your 2 on the outside. On your inside goes your coefficients from highest power to lowest power. So we have the 3x cubed, so that'll be 3. The negative 2x squared, that's negative 2. Negative 11x is negative 11, and 9 on the inside. We're going to drop down that 3, multiply it by the 2. That gives us 6. We combine it with the negative 2. That's 4. 4 times 2 is 8. 8 minus 11, or negative 11, plus 8 is negative 3. Negative 3 times 2 is negative 6. And 9 minus 6 is 3. Your 3 is your remainder. The negative 3 is your constant. The 4 gets an x, and the 3 gets x squared. So that gives you x squared plus 4x minus 3 plus 3 over x minus 2 for your answer. For number 3, you're using synthetic division and the remainder theorem to evaluate the following. You have p of x is equal to x to the 4th power plus 6x cubed minus 32x squared minus 28x plus 6, and tells you to find p of 4. So remember, that p of 4 means you're putting the 4 on the outside of your synthetic division. On the inside goes your coefficients of 1, 6, negative 32, negative 28, and 6. You're going to use your synthetic division to find your remainder. So your 1 drops down. 1 times 4 is 4. Add that with your 6, you get 10. 10 times 4 is 40. 40 minus 32 is 8. 8 times 4 is 32. 32 minus 28 is 4. 4 times 4 is 16. And 16 plus 6 gives you 22. So your remainder is your answer. So P of 4 is 22. For your next example 4, you're finding the 3rd degree polynomial with negative 2, 0, and 3 as your zeros. So you're going to set your negative 2 Why is this so thick? That's not even better. Equal to x. Your 0 equal to x and your 3 equal to x. So you're going to move these over, adding your 2 over. So x plus 2 is equal to 0. You're going to have an x also, and then you're going to subtract your 3 over. So you have x minus 3 is equal to 0 as well. So from here, you're going to take your x plus 2, and your x minus 3, and multiply them all together. I'm going to start with your x plus 2 times x minus 3. So you have x times x squared minus 3x plus 2x minus 6. From here, combine your like terms. So you have x times x squared minus x minus 6. Then distribute your x in to get x cubed minus x squared minus 6x. For number 5, you're finding all of the zeros in f of x is equal to x cubed minus 2x squared minus 3x plus 6. So we're going to take this polynomial, set it equal to 0, and because there's 4 terms, we're going to factor it by grouping. So we're going to group the first 2 and the last 2 together. From the first 2, we factor out an x squared. From the last 2, we factor out a negative 3. So this will leave us with x squared times x minus 2 minus 3 times x minus 2 is equal to 0. From here, your x minus 2 and that negative 3 form a binomial to give you x squared minus 3. And then you have that x minus 2. You cannot factor anything else out here, so you're going to set the x squared minus 3 equal to 0 and the x minus 2 equal to 0. Add your 3 over. You get x squared is equal to 3. And take the square root of both sides. And you get that x is plus or minus the square root of 3. For the x minus 2, add your 2 over. And you get that x is 2. So your 3 solutions here, because you have the power of 3, and that's your highest power, you have a negative square root 3, a positive square root 3, and 2. For number 6, we're finding the 4th degree polynomial with 1, 4, negative 3, and 2 as your zeros. So just like the one that we did 2 before this, you're going to set your 1 equal to x, your 4 equal to x, your negative 3 equal to x, and your 2 equal to x. You're going to move them all over to where you have x minus 1, x minus 4, x plus 3, and x minus 2. So we're going to FOIL out the first 2 and the last 2 together to get x squared minus 4x minus x plus 4, and x squared minus 2x plus 3x minus 6. These will both simplify to give us x squared minus 5x plus 4 times x squared plus x minus 6. So now from here, we're just going to multiply these out. So we're going to start with the x squared, distributing it into the second set of parentheses to get x to the 4th plus x cubed minus 6x squared. Then we're going to do the same with the negative 5x to get negative 5x cubed minus 5x squared plus 30x. Then we'll do the same with the 4 to get 4x squared plus 4x minus 24. we combine our like terms, and we'll be left with x to the fourth power minus 4x cubed minus 11x squared plus 4x squared gives us a negative 7x squared plus 34x minus 24. For number 7, you're telling whether the function shows a growth or a decay. Remember these, you're looking at your base. Your base is that term that's raised to the power. So you have f of x is equal to 0.67 to the power of 3x. The 0.67 is what you are comparing to 1. It is less than 1, so that means we have a decay. For our next example, we're given f of x is equal to 2 times 4.7 to the power of 3x. Your 4.7 is what you are comparing to 1. So you are going to say that it is greater than 1. So that means we have a growth. For number 9, it tells us that a total of $4,376 is invested into an account with an annual interest rate of 3.67% compounded monthly. We're finding the balance in the account after 7 years, and we're using the formula A is equal to P times 1 plus R over N to the power of N times T. So in this case, your P is the 4376. Your rate as a decimal is 0.0367. Your N, because it's monthly, is 12, and your time is the 7. So we're going to plug this all in. So you're going to use A of T is equal to 4376 times 1 plus 0.0367 over 12 to the power of 12 times 7. You plug this all into your calculator. Yes, you will need a calculator for your exam, and you should get 55.58. For number 10, you have a total of $5,000 that's invested into an account with an interest rate of 7.2% compounded continuously. You're finding the amount in the account after 12 years and using the formula A is equal to P times E to the power of R times T. So P is your 5,000. Your R as a decimal is 0.072, and your time in years is 12. So this is going to give us A of T is equal to 5,000 times E to the power of 0.072 times 12. Remember, you're dealing with money, so you're rounding to 2 decimal places. You should get $11,863.16. For your next example 11, you're evaluating the given function for each of the values that are given. So for the function, you're given f of x is equal to 2 times 0.37 to the power of 4x. For a, you're finding f of negative 0.47. So you're going to plug that in for your x. So you're going to get 2 times 0.37 to the power of 4 times negative 0.47. You are rounding to 3 decimal places here, so this should give you 12.966. For b, you're finding f of 1.2, so that's going to be 2 times 0.37 to the power of 4 times 1.2. So that'll give you 0.017. For C, you're finding f of 6/7, so that's going to give you 2 times 0.37 to the power of 4 times 6 over 7. So that'll just simplify to give you 0.066. For number 12, we're writing the exponential equation in log form. So we have 7 to the power of 5 is equal to 16,807. We're going to drop down that 7 as our base. The 5 is going to become our answer, and that 16,807 becomes the number after that log. So it's going to give us log 7 of 16,807 is equal to 5. For 13, we are evaluating log 5 of 625. So this is the same thing as asking 5 to what power is 625. 5 to the 4th power is 625. So your answer is just the 4. For 14, you're using your properties in order to simplify. You have log 9 of 9 to the power of 15. Because your base is the same with the 9s, they cancel, and you're just left with the 15 for your answer. For 15, you have e to the power of your natural log, or ln, of 4.82. Your e and your ln cancel each other out, so you're just left with the 4.82. For number 16, you have the natural log of e to the power of 11.9. Again, ln and e cancel each other out, and you're just left with the 11.9. For 17, you have 5 to the power of log 5 of 17. Your 5 is the same as the base on that log, so they cancel each other out, and you just have the 17. For 18, you're going to use your calculator with the change of base formula to simplify and round to 3 decimal places. It gives you log 7 of 43, so we're going to take the log of 43 and divide it by the log of 7. This should give us 1.933. For 19, we're condensing to one single logarithm and simplifying if possible. When we say condense to one log and simplify, it just means to simplify like improper fractions or fractions where your numerator is greater than your denominator and they share a common factor. It does not mean to simplify like you did with the last question and actually find the, or use the change of base formula. So you are not using the change of base formula for these, you're just simplifying. So for this one, you have log 2 of 11 plus log 2 of 6 is being subtracted with log 2 of 3. Within your parentheses, you have addition, so you're going to rewrite this with multiplication. So it'll be log 2 of 11 times 6 minus log 2 of 3. We're going to multiply that 11 times 6 to get log 2 of 66 minus log 2 of 3. From here, you have subtraction, which is representing division or fractions. So that gives you log 2 of 66 over 3. 3 goes into 66. So you're going to simplify that fraction. That's what it means when it says to simplify. So this should give you log 2 of 22. For 20, you're doing the same thing, but now you have 1/3 times log 3 of x plus 5 times log 3 of y, all subtracted with log 3 of z. Your 1/3 is going to become the power on x, and the 5 becomes the power on y. So this will give you log 3 of x to the power of 1/3 plus log 3 of y to the 5th power minus log 3 of z. Your power of 1/3 is going to turn into the cube root, so that's going to give you log 3 of the cube root of x plus log 3 of y to the 5th power minus log 3 of z. From here, you're going to rewrite the addition as multiplication. So you are going to have log 3 of the cube root of x times y to the 5th minus log 3 of z. Now when I rewrite this, I'm going to put that y to the 5th in front of the cube root of x, so that way it's not confusing to where that y to the 5th is underneath that radical also with the x. So it's going to give us log 3 of y to the 5th power times the cube root of x minus log 3 of z. Lastly, you're going to rewrite your subtraction as division or a fraction. So that'll give us log 3 of y to the 5th times the cube root of x all over z. For number 21, it tells you to expand log 2 of w to the 4th power times the cube root of x all over 3y squared. This is the same thing if you rewrite that radical as log 2 of w to the 4th x to the 1/3 power over 3y squared. From here, you're going to rewrite the fraction as subtraction. So it's going to give you log 2 of w to the 4th times x to the 1/3 power minus log 2 of 3y squared. You have multiplication between the w to the 4th and the x to the 1/3. You also have multiplication between the 3 and the y squared. So you're going to separate using addition. So you're going to have log 2 of w to the 4th plus log 2 of x to the 1/3 power subtracted with log 2 of 3 plus log 2 of y squared. From here, you need to make your powers coefficients. So the 4, the 1/3, the 2 are all going to be moved to be in the front of that log expression. So you're going to have 4 times log 2 of w plus 1/3 times log 2 of x minus log 2 of 3 plus 2 times log 2 of y. Number 22 is going to be just like 21, where it gives you log 4 of 6x squared times the square root of y over 5z to the 4th power. For this one, you're going to rewrite your radical as the 1/2 power. So you have log 4 of 6x squared y to the power of 1/2 all over 5z to the 4th. From here, you're separating using subtraction. So that's log 4 of 6x squared y to the 1/2 power minus log 4 of 5z to the 4th. Now you're going to separate all your multiplication using addition. So that becomes log 4 of 6 plus log 4 of x squared plus log 4 of y to the 1/2 power minus log 4 of 5 plus log 4 of z to the 4th. Lastly, you're going to move those powers to be coefficients. So that's the 2, the 1/2, and the 4. So that'll give you log 4 of 6 plus 2 times log 4 of x plus 1/2 times log 4 of y subtracted with log 4 of 5 plus 4 times log 4 of z. For your next one, number 23, you're condensing the expression to represent one single logarithmic expression. So it gives you log 2 of 5 plus 1/3 times log 2 of x minus 6 times log 2 of y plus 4 times log 2 of z. So first thing we're going to do is we're going to move those coefficients to be exponents. So that gives us log 2 of 5 plus log 2 of x to the power of 1/3 minus log 2 of y to the 6th plus log 2 of z to the 4th. From here, we're going to rewrite that fractional power as the cube root. So it's going to give us log 2 of 5 plus log 2 of the cube root of x minus log 2 of y to the 6th plus log 2 of z to the 4th. From here, we're going to rewrite the addition as multiplication on both sides of that subtraction sign to give us log 2 of 5 times the cube root of x minus log 2 of y to the 6th z to the 4th. Lastly, we're going to rewrite the subtraction as division or your fraction to give you log 2 of 5 times the cube root of x all over y to the 6th z to the 4th. For number 24, it tells you to solve and keep your answer in fraction form if necessary. For this one, you have log 5 of x minus 2 is equal to log 5 of 4x minus 7. Because the base on the log is the same on both sides, they will cancel out, and you will just work with the x minus 2 is equal to 4x minus 7. You're going to move your x over, subtracting it from both sides. That gives you negative 2 is equal to 3x minus 7. From there, add your 7 over. That gives you 3x is equal to 5. Divide each side by the 3. And you have that x is 5/3. For 25, you are solving log 3 of 2x plus 9 is equal to 4. Your base is the 3, so you want that base to be the same on both sides. So this becomes 3 to the power of log 3 of 2x plus 9 is equal to 3 to the 4th power. Your 3 cancels out your log 3 to give you just 2x plus 9 is equal to 3 to the 4th power, which is 81. You're going to subtract your 9 over to get 2x is equal to 72. Divide each side by the 2, and you have that x is 36. For 26, it tells us that a truck is purchased for $78,500. We're using the formula A of t is equal to a times 1 plus or minus r to the power of t to determine between what 2 years the truck will be worth $17,500 if it depreciates by 15.2% each year. So we're depreciating, which means we're going to use subtraction with this. Our A is the 78,500. Your A of t is your ending amount, which is the 17,500. You are subtracting, and your rate is going to be 0.152. So this is going to give you 17,500 is equal to 78,500 times 1 minus 0.152 to the power of t. We're going to subtract to get 17,500 is equal to 78,500 times 0.848 to the power of t. We divide each side by the 78,500. This leaves us with 35 over 157 is equal to 0.848 to the power of t. We're going to take the log of both sides. So this is going to become log of 35 over 157 is equal to the log of 0.848 to the power of t. From here, we're going to move our t over to give us log 35 over 157 is equal to t times log of 0.848. We're going to divide each side by the log of 0.848. And that should give you t equaling 9.10. So if we're going between what 2 years, that means that it's between 9 and 10 years. For number 27, it tells you that the population of a town is currently 47,429. You're using the same formula that you did in the question before this to determine between what 2 years the population will grow to be 53,000. If the population grows at a rate of 6.8% each year. So with this one, your rate or your population is growing, so you're going to be using the addition part of your formula. Your A is the 47,429. A of T is the 53,000, and R is 0.068. So this will give us 53,000 is equal to 47,429 times 1 plus 0.068 to the power of t. We're going to add to get 53,000 is equal to 47,429 times 1.068 to the power of t. We divide each side by the 47,429. So this will give us this will give us the 53,000 over 47,429 is equal to 1.068 to the power of t. We're going to move our t to the front of this once we take the log of both sides. So that's going to give us the log of 53,000 over 47,429 is equal to t times the log of 1.068. We're going to divide each side by the log of 1.068. Plug that into our calculator, and we should get that t is 1.688. So that just means that it's between 1 and 2 years. For our next question, number 28, you're stating whether the ordered pair -7, 0 is a solution to the system. You have 2x plus 5y is equal to -14, and 6x minus 4y is equal to -42. Your -7 is your x, 0 is your y. So we're going to start with the top equation to give us 2 times -7 plus 5 times 0 is equal to -14. Your 5 times 0 cancels out, and you have -14 is equal to -14. That is a true statement, so we will check the second equation. For the second equation, you have 6 times x, which is -7, minus 4 times y, which is 0, is equal to -42. Your 4 times y cancels out, so leave you with -42 is equal to -42. This is also a true statement, so yes, the -7, 0 is a solution. For 29, we're given the ordered pair 2, 5, and the system -5x plus 4y is equal to 31, and 7x minus 6y is equal to -47. The 2 is our x, 5 is our y. Starting with the top equation, it's going to be -5 times 2 plus 4 times 5 is equal to 31. Your negative 5 times 2 is negative 10, and your 4 times 5 is 20. This leaves you with negative 10, or sorry, positive 10 is equal to 31. This is a false statement, so that ordered pair of 2, 5 is not a solution. For 30, you're using the substitution method to solve. You're given the system 3x plus y is equal to 5 and negative 2x minus 3y is equal to 6. We're going to take the top equation, solve it for y. So we're going to move that 3x over, subtracting it from both sides. That gives us y is equal to negative 3x plus 5. Because we're using the substitution method, we're going to take that negative 3x plus 5, plug it in for y in that second equation, and solve for x. So it's going to give us negative 2x minus 3 times negative 3x plus 5 is equal to 6. We're going to distribute the negative 3 in. We'll have negative 2x plus 9x minus 15 is equal to 6. Combine your like terms. That's 7x minus 15 is equal to 6. Move the 15 over, adding it to both sides. So that's 7x is equal to 21. Divide each side by the 7, and you get that x is 3. You still need to solve for y, so you're going to plug that 3 in for the x value, and y is equal to negative 3x plus 5 to solve for y. So it'll give you y is equal to negative 3 times 3 plus 5. That simplifies to be negative 9 plus 5, which is negative 4. So your ordered pair, that is your solution, is 3, negative 4. For 31, we're still using substitution, but given the system y is equal to 2x minus 8 and 3x plus 4y is equal to 10. Your first equation's already solved for y, so we're just going to plug the 2x minus 8 in for y in the bottom equation. So it'll be 3x plus 4 times 2x minus 8 is equal to 10. Distribute the 4 to get 3x plus 8x minus 32 is equal to 10. Combine your like terms. That's 11x minus 32 is equal to 10. Add your 32 over. That gives you 11x is equal to 42. Divide over the 11. So you have that x is 42 over 11. You're going to take that 42 over 11 and plug it in for x in the top equation to solve for y. So that's going to be y is equal to 2 times 42 over 11 minus 8. The 2 times 42 over 11 gives us 84 over 11 minus 8, which is the same thing as 88 over 11. Remember, you need like denominators in order for you to add or subtract fractions. So this leaves you with negative 4 over 11 for y. So this gives you 42 over 11, comma negative 4 over 11 for the answer. For 32, you're using elimination with addition to solve the system. You're given 2x minus 4y is equal to 11, and 3x plus 4y is equal to 14. Your y's are opposite, so you can just combine like terms to give you 5x is equal to 25. Divide each side by the 5, and it gives you x is 5. From here, you're going to choose one of the original equations and plug that 5 in. I'm going to use the top to give us 2 times 5 minus 4y is equal to 11. The 2 times 5 is 10, minus 4y is equal to 11. Subtract your 10 over. That gives you negative 4y is equal to 1. Divide each side by the negative 4. And you have that y is negative 1/4. So that gives you 5 comma negative 1/4 for your answer. For 33, you're using elimination with subtraction this time. Given the system's negative 3x plus 2y is equal to 13, and 3x, or negative 3x, plus 4y is equal to 17. Your 3x's are the same. We want them to be opposite, so we're going to change the sign on everything in the bottom equation to combine. This cancels out your 3x's, gives you negative 2y is equal to negative 4. You divide each side by the negative 2 to get y is 2. I'm going to take that y, plug it into the top equation to solve for x. So that'll give us negative 3x plus 2 times 2 is equal to 13. That simplifies to be negative 3x plus 4 is equal to 13. Subtract your 4 over to get negative 3x is equal to 9. Divide each side by the negative 3, and you have that x is negative 3. So use your x and your y to get negative 3, 2 as your ordered pair. For 34, you're using back substitution to solve for x minus 2y plus 7z is equal to 1, 2y plus 3z is equal to 9, and z is equal to negative 1. So you're going to take that negative 1 and plug it in for z in that second equation to get 2y plus 3 times negative 1 is equal to 9. This gives us 2y minus 3 is equal to 9. We add our 3 over to get 2y is equal to 12. Divide each side by the 2, and you have that y is 6. We're going to take this 6 and the negative 1, plug it in for y and z in the top equation to solve for x. So that'll give us 4x minus 2 times 6 plus 7 times negative 1 is equal to 1. That simplifies to give us 4x minus 12 minus 7 is equal to 1, which is 4x minus 19 is equal to 1. Add your 19 over. That gives you 4x is equal to 20. Divide each side by the 4, and you have that x is 5. So that gives us the ordered triple as 5, 6, negative 1. With 35, you're doing the same thing. So you have 2x plus 3y minus 2z is equal to 23. 3y plus z is equal to 11, and z is equal to 6. So I'm going to plug that 6 in for z in that middle equation to get 3y plus 6 is equal to 11. Move the 6 over, subtracting it from both sides. So that's 3y is equal to 5. Then divide each side by the 3 to get y is 5/3. We're going to take our y and our z, plug it in to the top equation to get 2x plus 3 times 5 over 3 minus 2 times 6 is equal to 23. This gives us 2x plus 5 minus 12 is equal to 23. Combine your like terms. That's 2x minus 7 is equal to 23. Add your 7 over. That's 2x is equal to 30. Divide each side by the 2, and you have that x is 15. So that gives you the order triple 15, 5/3, 6.